Assalamu alaikum, everyone. I hope everyone is doing fine. And although today is the session number 2, but last week, because last week, I had to cancel the class. So today I'm going to be covering quite a lot of ground. And although I have planned this class for 2 hours today, but if maybe at the top of the hour, we'll see if how you guys are doing. If you wanna if a break or you wanna continue on. So based upon you know um your feedback, we'll decide should we continue on for the full 2 hour or should we just pause and then maybe uh, resume next week on that because quite a lot of topic to cover plus quite a lot of grounds we're going to be covering and the fairly new for you guys. Uh, all right, so let's get started. For those of us who are joining us for the first time, my name is Faisal Abbas. I am based in Chicago. And this program is, this course is being offered as part of a bundle program that we are offering. We have 4 other courses that we are offering, throughout the week. And this is one of those. Um, and this course, so we record the session. If you have not received the slide deck and the recording of our previous session, reach out to me. I have uploaded to my YouTube channel, and please like and subscribe to the channel. Thank you. All right. So as I mentioned, this is our session number 2. Let's do it. Let's make it a session 2/3. This week, I read it somewhere on LinkedIn, and that thing actually hit me. And you see this, a quote here that master AI before it masters you. And this is right there, for us. So this is the right time for us to start on this journey, master this trade, this technology, because this is the future. This is the technology which is going to impact pretty much every walk of the life, every industry vertical, every area, no matter wherever you are working on. This is going to impact us all. So master it as early as possible. Use this course as a conduit. Use this course as a stepping stone. Use this course as a catapult you into the deep side of the deep end of the AI. And in one of the slide, I actually while I was preparing for the slide, so there is one slide which I thought that it will be helpful for you guys to get some better understanding how if somebody wanted to step into the AI domain. So AI is a very general term, just like cloud is a very general term. There are several different areas within cloud. Similar case with the AI as well. There are several different areas where you can find your niche or pinpoint yourself or go specific in that specific area, find the niche and grow your career and grow yourself in that. All right, moving on next. So here's the outline. We're going to be covering some additional fundamental concepts. Those concepts will be weak and strong AI differences. What are those? What is a weak AI? What is a narrow AI? What is a strong AI? Then a couple of topics around the data, a couple of topics around the algorithms, features and labels, and the confusion matrix and the confidence level. So we're gonna cover those as well. Right after that, we're gonna try to get some understanding on machine learning. We're going to try to define its types, its categories, how it is different, what is the supervised and the unsupervised side of it, what are the regression and the classification algorithms, what is ML ops, what is the importance of data in machine learning, why is data important, all of a sudden you start hearing, hey, data is the new oil, data is the new king. what is happening? Why? I mean, data was there, that everything was generating data in the past as well, but all of a sudden, what happened? So we're going to look into that aspect as well. And then we're going to look into the if time permits, natural language processing or NLP. We're going to define it. We're going to look into its applications. And then, what is computer vision? We're going to try to define that, look into the definition, look into the explanation of it, and, its application in our daily life. So quite a packed agenda for today. So let's get started. And I'm not trying to shove everything down to your throats, for the lack of a better term. If you feel that um, right after the fundamentals, we have covered quite a bit, and let's just push the machine learning to the following week. I'm okay with that. Or you feel that we can proceed with machine learning, and let's just stop the learning by machine learning, and then the NLP and the computer vision, we're gonna do it the following week. I'm all okay, with everything. So I'm here at your service. So however you guys are comfortable with, because there will be a lot of new terminologies, new lingo, new tech, new stuff coming down your way. So I want you to be comfortable. I don't want you to dozing out. Hey, Faisal is just, shoving down, shoving everything down our throat. And I'm not here to just, read through the slide and, uh, at the top of the hour, just mark it complete. This is more to give you guys a confidence level that, hey, I am understanding, I am trying to learn this new thing, and so I'm trying to piecemeal as much as possible every single concept, so that you have something better to understand, or some better understanding of that specific area. All right, so enough of that. Let's move on. If you guys remember, so before I start on this, on my first session, I actually realized I made a mistake. I wanted to make it correct here. I mentioned that in OpenAI, ChatGPT, Microsoft made an investment of 49 billion, although it was 10 billion, not 49. But the Microsoft, how they turn out the deal is they're going to be owning the 49% of the share of that, the entire OpenAI. But even, for 10 billion is quite a big number. Okay, so last week we've paused here our session, that where we were going to discuss the types of AI. On the left-hand side, left-hand side of the screen, you are seeing a diagram which is showing the types of AI: narrow AI, general AI, super AI, and then right-hand side, reactive, limited memory, theory of mind, and self-aware AI. So we're going to look into the left-hand side of it, what is narrow and super AI. And then we're going to go deep dive on the right-hand side. On the right-hand side, where you see the machine learning, deep learning, sorry. So this area, we're going to be covering a lot of ground in this area. What is actually not the deep learning today. We're going to be covering what is a supervised learning, what is unsupervised learning, and there is a third area as well of machine learning. So we're going to look into what is a machine learning, and then what are the branches of machine learning. So we're going to go deep into it, and what are the examples of it. So I try to pick regular, normal, day-to-day examples for us. Plus, I know that there are a couple of, high school and college kids with us here as well. So I actually pick some examples from academic side as well. So to make you guys, to bring you guys up to speed, that how can I put that into my academic area, and uh, give you guys a confidence level that AI can help you out in your academics as well. It's not just only for the for the regular day-to-day or the job or the business work, but also on the academics as well. It is showing its its potential as well. All right. So the very basic concept or the very basic building block in building any system, be it an AI-based system, cloud-based system, or legacy system, or application, or whatever, or whatnot, right? The building block, one of the basic building blocks is the data. What is data and what is its importance? So data is a critical component, not just only in AI ML, but like as I mentioned, everywhere overall, be it any application or be it a cloud-based system or be it a legacy system, or on-prem system that we are building or that has built and we are supporting it. So it provides the raw material that algorithms consume to learn the pattern and help make predictions. A couple of things popped up here. One is the algorithm. So I actually have a slide, actually two slides on algorithm. What is an algorithm? You must have heard this word quite a lot. You have heard the word data as well quite a lot. So what is the definition of those? What is a data? What is a data set? What is an algorithm? What is an AI algorithm? So we're gonna be um, you know, uh, as I mentioned, going, deep dive into it. So data is the critical and the fundamental component of any of the systems. It is the raw material that is going to be consumed by the algorithms. So hold off to the definition of algorithm for now. It is going to consume by the algorithms to learn and make predictions off of that raw data or raw material. So we have the raw material, it could be a text. So what are the types of the data? It could be, you see that, it could be numbers, it could be, some facts, it could be observations, measurements, the weather measurements, or, maybe measurements of your house, and some information, some graph. It could be of any type, it could be numerical data, it could be categorical, like categorize, some categories, such as, colors, brands, or, the job titles, right? So it could be of numerical in nature, say, you are collecting, let's say, how many students in sixth grade are boys and how many are girls? What are their average heights? Or what was the temperature of Chicago last year, the same day? Like February, was that February 17th, 2022, what was the temperature of Chicago? Um, you know, um, or, it could be of discrete nature, what is the average age of, people who, uh, who do, X work or, Y work, right? So it could be of, numerical in nature, it could be a text in nature, it could be an image, like photos in our iPhones or our smartphones or our smart devices, right? So, we take tons and tons of pictures, in our on our phones now, on our smartphones, it could be, X-ray imaging or MRI imaging, so image could be of, any type, So spectrum is always broad. That's why it is called a raw material, because it has a broader spectrum. It has tons and tons of material sitting there. Now it is up to us how we are going to deploy a model or how we are going to utilize that raw material for our benefit. It could be, a time series data. Time series data are those, that are, progress over a period of time, as an example, the stock tickers, when the stock market starts up until the stock market ends or stops, for the specific day, you see the stock tickers, going up and down, so every whatever the interval they have, every minute or every hour, they are collecting that data, that stats. So that actually progresses over a series, over a time series. So that's, they are called the, time series data. They could be used for forecasting or, predicting, something, like forecasting, forecasting of the weather, the weather forecasters, they normally use, this time series data. Like, is it going to snow in Chicago? Is it going to be, a sunny day, say in Karachi, So, based on all that, right? So, and then, they predict, how the future looks like. Same is the case, another type is audio data. So these types that you are seeing here, they are not this is not the exhaustive or the comprehensive list. These are, some of the examples which I picked just to, give you guys, some understanding of what a data is. So data is a raw material that is going to be used for a bigger picture or for a processing or bigger processing that is going to help um, could be that could help my business out, that could help help me out, be a better person, could help a community out, could help a student out, or could so the use cases are endless, and it depends what purpose I am going to use it for, for my future use. So, example of the audio is, such as, the music or the speech or the environment noise or whatever, right? So, these are, some of the examples. I'm going to pause here for any questions or comments, anything, or is it all, if it is all making sense to you guys, just, in the, on the top of your screen, you will be seeing some icons. One of the icon is for the raise or the react. So you can click on the react and give me a thumbs up, or so that I could proceed further on it. Or if you have any question, feel free to unmute and ask a question, please, because this is an important concept that I want you to be fully aware of. Many years ago, maybe Y2K, trying to type something in Google. Okay. And it starts. All right. I see some thumbs up here. Okay. So let's proceed forward. So, sorry, you are so the data makes sense, right? So what is the data? You see that, it could be quantities, it could be information, graph measurement, facts, figures, audio, time series, or graphic or whatever, right? So it could be of anything, right? Next one is the data set. You will be hearing this word quite a lot in AI field. Or if you are in IT field, you must have heard this quite a lot lately already. What is it? What is a data set? Yes, Mohsen, in my next slide, next, I think 2 or 3 slides, I'm going to be discussing, and I'm going to explain you guys what is an algorithm and what is an AI algorithm. So yes, so tight, rest assured, yes, you will be, yeah, we will be covering, that area as well. Okay, so question of the minute is, what is a data set? So as data is clear to you guys, data set is a collection of data. So it is a collection of the data that was collected in the past of some form or shape, could be audio data or text or whatever the type may be, right? So it is a collection that is usually organized in a tabular form. Usually it could be in a text form. So data set doesn't need to be organized in a tabular form. It could be an unorganized data. As long as it is just a collection of those facts and figures, that is called the data set. It is in AI, it is used to train and evaluate machine learning models. And we're going to be seeing, we're going to be, hearing more about or learning more about what is training and what is the evaluation on the machine learning side. Now, like what are the patterns and the relationship in the data, and how do we use them for the predictions or for the decisions, off of those, or maybe infer something meaningful out of it. So that's the main purpose of the data set. Machine learning algorithms, they are trained on a large data set. So what is a large data set? So a data set, could be a collection, let's say an attendance roster on Excel sheet, say of this class. Or it could be, how many uh, how many Teslas are there, in the on the road these days, or or it could be, a metro train schedule, or those who are in Toronto, what is the the go train schedule, for the next or maybe for the last, let's say 20 years. So, whatever was collected there, so, that is the, the collection of it. Um, Here's one thing which is of importance is data can be publicly available, or data set can be publicly available or privately, to be used by the organization. Some organizations, they keep the data to themselves. They do not, dissipate to the outside world. It could be a trade secret, it could be a business secret, or it could be something that, if my data get um, exposed to the outside world. It could be a security threat for my business, or it could be somebody will maliciously use it, or maybe I may have my business just run down because of that. So they keep it secure to themselves. But there are some organizations, they put the data out there publicly. Mainly the governments, they put the data out there publicly. As an example, COVID-19 data that is currently available publicly for, like, it's the global data that you can access. US Census Bureau, Canadian Census Bureau, I think Pakistan Census Bureau as well, and they publish their data. So so you have that big data set. As an example, US population 313 million people, Pakistan population over 220 million, right? Somewhere around that. Um, so this big data, millions and millions of rows and millions of, data, a data set is available out there publicly that you can use, that you can consume and make, you can train your models and you can, infer something meaningful, out of it. So the data is available out there. Two examples I put in there is, Kaggle.com. You might want to, go to that site and look into it. And also, data.gov as well. Data.gov is a US government website. You can go to the website and collect the data, or they have, tons of different data sets available. Let me just quickly go over and show you guys. This will be of, good, this will be a good exercise for you guys. Maybe not for this course, or maybe for this course. But this will be helpful for you. Let's say if you are doing any analytics job, or learning anything related to analytics, maybe if you're learning Power BI, or if you're learning something analytics related in Excel. So, how do you, like, the raw data is there. How does that data make sense to me if I wanted to learn, so that I could be a resourceful person, in my organization, or within my business, or at my school. So, the data sets, they are available, and that is going to help you out in your career or in your future endeavors. So let's just go to data.gov. Okay. So Ahmad, I'm going to come to your question in a bit. Let me just quickly go over this with you guys. Is it more readable to you guys, or let me just increase the size? Okay. So data.gov, you see that there are over 300,000 different data sets available publicly at this time on data.gov. So you can pick whatever, you feel like, it's appropriate to you, for you to, do some research, or play around, or do the analytics work, or do the, like, building the plots, and, plotting the charts and all that, to make some sense out of that data. It is right there available for you. They have the, coronavirus, they have a different site that is, for the corona specific. So let me, if I just, maybe I just type here, electric vehicle. So I'm just typing some general question here. So you see that, it is giving me 2,100 different data sets. They have the word electric vehicle in them. It could be EV population data, EV population size and history. And you see that, there are different types of data. Like, data is available in different, or data sets rather, are available in, different types and formats, like CSV, like RDF, or JSON, or XML. How you want to, consume it for your, into your application. Um, so this is just to, give you an example. there are, tons and tons of, different examples available here. I would recommend you guys to go to that site, maybe, collect or maybe download something or search something which you feel is going to be of attention for you. Download that, review that, and see, how it is, going to help you out, learn or be a better person, understanding, the aspects of, data and all that. Okay. All right. So yeah, these are, two of the examples. There are more examples out there. I'm not gonna go in detail. Try to go into Kaggle.com and see, what type of data sets, they have available. They have mainly large data sets available for data science projects, and people upload there, and you can, compete. They have, like different competitions. Those are paid competitions, and also, learning for your learning as well. If you want to learn, if you are interested in learning more the algorithms and what is the best algorithm that I need to, put into that specific data set to collect or to infer the meaningful results out of it. So yeah, kaggle.com. Yeah. Go visit that as well, along with data.gov. All right. Next one is the features and labels. Um, this concept is pretty important for any person who is going to venture into AI ML area. Here you see the two concepts, and they both are very commonly used in machine learning. One is called the feature, the other one is called the label. What is the attributes of feature? So features are the input variables and labels are the output variables. Keep this in mind. Just keep repeating that. Keep repeating it. Maybe every day. Keep repeating after your Fajr, Zohrs, and Asr Salat, and just remember that feature is the input variable and label is the output variable. Okay, what is the purpose of it? Um, Features are, they are the characteristics that are used to describe the data. That, this is the feature set of my data. This describes my data. Hey, my data is, it has, let's say, this many fields, and this is specific to this specific industry, or it is related to, let's say, this is specific class. This it is related to this specific, weather forecast, or this specific geographical location. So it defines the characteristics that, what is that data set overall. It can be, you can think of it as a variable X. Those of us, who were like who studied maths, or in any shape or form, either by themselves or they interacted with math, like they have to teach their kids, or get the better understanding, or they are doing it, or they did it, for their learning and for the betterment. So consider this as an x variable that we have in mathematics. Remember, in mathematics, normally the question is, hey, find the value of x, or what is the value of x when these are certain certain equations are given to you. So feature is the value of x in that equation. It could be quantitative, say, the age or height or weight, or it could be categorical, the gender, color, brand, or whatever and whatnot, some of the examples. So feature is the input variable. At this time, just remember this, and in subsequent slides, things will start making sense to you guys. On the right hand side, you see some examples of features, like in the predictive model. Um, uh, Let me just hold off to this example. Let's take the second example. Predictive model for determining the likelihood of a credit card user defaulting on payment. So if a user is if a person is using a credit card. And so what is the chances that person is going to default or may not be or not able to make the payment, going forward. The feature could be the number of, previous missed payments, or the, so these are, some of the features that are given in the data set. And based off of that, we're gonna create our prediction model. So what are the features that were provided to us is the number of, missed payments, the credit limit, the age, or, could be, different other, features out there. So based on these features that are provided to me on a data set, consider or think of the data set as an Excel sheet that has, let's say, 1 million records in it. Out of those 1 million records, there are, different fields. Out of those fields, the couple of fields are, the payment, let's say payment deadlines, and, the credit limit, the age, the geography, and, a couple other, right? So out of those, columns, let's say, these are, some of the columns that are of, importance for us to make a prediction that if a person is going to, default on that loan or not. So that's one example. Another example, you see another example. This is also a predictive model example, where on the, this is on the churn rate of the, telecom users. The feature could be number of service calls made, the length of time, the type of service package subscribed to, and, things of that nature. So that's, another example of, feature out there. There are more examples as a homework. I would recommend you guys to at least find maybe 3 to 4 different examples of features. Like if in a data, if let's say if you are given a data set, what features are provided to me, and based on those features, what level of prediction can I make? Let me this is a good segue. Give me 1 second. Let me pull that one spreadsheet for you guys. I was able to download one Excel sheet for you guys from the, that was for a different purpose, but let's just, pull it up in here. This is the spreadsheet which I pulled up from data.gov this morning. And this was, about the EV charging stations. So let me do this. I'm gonna copy the, let me go to this. I'm gonna, these, so these are the fields I have. Okay. These are the fields, or this is the feature set I have. Feature set based off of this data set. Okay, I have this data set, which is this. Okay, I have what about there are about some 336. So a little over 300 records I have. This is the data set I have. Based off of this data set, this is the feature set. Remember, the feature set is what? Feature set is the input variable. It gives me, it is the input or the characteristics of the data, or it is the metadata, or it is the correct. Let's not use the metadata. It is the characteristic of the data set. Tells me that these are the features available. Now, what level of inference or what level of educated guess I can make off of uh, these fields. It could be something, number of stations, and in cities I can infer something that let's say in the city of Chicago has more charging stations than the city of Toronto, as an example. So, how did I come up with this, prediction or this inference based off of, this feature set that is available to me. Does that make sense to you guys? Or do you want me to go deeper into it? Just give me thumbs up here and there, so that I would know that you guys are with me. Are you guys still awake? Do you guys need a coffee break? Should I proceed further? Is it making sense? Or do you want me to repeat this? Feel free to unmute, please. Unmute or yeah. Okay. All right. I see two thumbs up here. All right. Perfect. Okay. Sounds good. So these are the feature sets I have. Now, based on those feature sets, we can predict, we can create a prediction model and then use that for some meaningful insights for our business or for myself. Okay. All right. Okay. All right. So this was the feature set, right? Now, let me just minimize this. Now let's go and check what is the other aspect of it. The other one is the labels. Okay. Features were the input side, the fields that were given to me. I can I can infer the results out of those, right? So that's the input set for me. Now for the labels are the output set, output variable for us. Labels are the output or target variables that we are trying to predict. What we are going to predict, that is called the label. Let's say if let's say on a computer vision um, application or AI model, if I show this to a computer vision model, it is going to label this based off of the feature set was given to it. It is going to label this as a mouse. If it is labeling it as a mouse, that means uh, my ML model is resulting 100% or resulting perfect results what I am looking for. If it is labeling this, so label is the output. So say if I show this to uh, my ML model, and if it labels it as a mouse, that means that it is not predicting what I am looking for. Or if I ask if this is a pen or a vaping device, if it labels it as a pen, or if it says yes, a pen, that means that it is predicting or it is giving me the right label or it is predicting in the right direction. So labels are the output or the answers. So you will be hearing more down the road. Um, these two uh, terminologies, features and labels. So label is the output. They can be thought of as y variable in a mathematical equation. So let's say now if you have equation y equals a square plus 2ab plus b square. So what is y? Y is the resultant, or y is um, the output what we are looking for. So we are looking for a value of y in this specific equation. There are more examples, like label could be binary, yes or no, true or false, 1 or 0, or it could be multi-class, say the mouse or pen, or could be a color, red, blue, or green, so whatever the description we provided for the label, based off of that, it will give us the output. Hey, if this is an apple or not, or if this is an orange or not, just to, as an example. On the right hand side, you are seeing some examples of the model. There are two examples I picked. One is whether the customer will purchase a particular product or label. Could be yes or no, depending on whether they actually made a purchase. As an example, you go to Amazon.com. Let's say you picked one product, two product, three products. you put those products into your um, into your cart. You haven't checked out yet. They are in the cart. You go again on your onto your Amazon shop. It will start showing you things related things of that nature. So that's that's another example of it. The another one is like different species of flowers and label them. Say differentiate among rose and the daisies and tulips. There was one application last year, I think it was last year or a year before. I have it somewhere. Anyway, so what does that application do is um I wish I could find that for you. So what does that app is, so you point your camera, like you turn on that app, you point your camera to that, let's say if it's a weed or if it's a the actual flower or if it's a type of grass or something, whatever in your backyard, you just take a picture. The app will tell you more like tremendous amount of details you get from that. Like if it's a seasonal, if it's a if it's a flower, if it's a fruit tree, or if it's a just a weed that is growing in the summertime. um and what are the restrictions on it, how do you kill it, or how do you maximize your growth on it. There's tons and tons of information that you get from that. So I do not have to go to Home Depot, you know uh, say I take a leaf of it and then take it to the Home Depot. Hey, I want to kill this. It is eating my yard. So based instead of that, I can take a picture right there through the app, and that app actually helps me out. So this is another model, another example of labeling based off of the prediction, or based off of the feature set that was given to it. So as a um, 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 to summarize this, features are the inputs and labels are the outputs. So if something if any of the model coming back to you with an answer, that answer is called label in in AI world. Let's just put it this way. Okay, I have one example here. I have to. I think I'm gonna have to. Maybe I'll send it to you guys as a homework. So there was one equation I had. I wanted to challenge you guys, with that equation. Anyways, maybe I'll send it to you guys as a homework for you. Okay. All right. I'm gonna pause here. Are you guys clear? Okay with the features and labels, or just give me maybe a thumbs up, or mute, or any questions. So can we say feature is a question and yes. Let's just put it this way. Feature is not a question, but feature is let's say those options that were given in the question. Uh, so let's say it's a multiple choice question. You have like four options. So those options are the features for you. Let's put it this way. Okay. All right. Okay. All right. So if no further question, let's move on to the next one, which is what is an algorithm? I think one of the brother asked about this question. Okay. Yeah. So somebody asked this question. Okay. So this all right. I'm sorry. Okay. You guys must have heard this word in the past, and you will be hitting more if you are going to step into or venture into AI ML world. What is an algorithm? Um, we use this word quite a lot, in maybe like in our technical conversations. But what it is, so algorithm is a set of well-defined instructions. The emphasis on well-defined, and I'm going to come to it in an example. So it is a set of well-defined instructions that are used to solve a specific problem or perform a specific task. The emphasis on three things here: well-defined, emphasis on well-defined, a specific problem or a particular task. It is a set of well-defined instructions, and it is important for you guys to understand this. A specific set of instructions to perform a specific problem or perform a specific task or solve a specific problem. Essentially, it is recipe that computer follows to solve, step-by-step processes. I'm going to come to the diagram in a bit. You see some common examples down below, like recipe of baking a cake. It is not a recipe of your mom cooking a biryani. It is a recipe of a cake that a baker has published for his folks that, um, oil this quantity, whatever the X quantity is, water this much, and the flour this much, bake at this temperature for this, exact period of time, so like, all those steps, well-defined instructions, all those steps are defined so that, if the baker is, the master chef is not available, the sous chef or, someone who is aspired to be a chef, or a baker, pick that recipe and try to recreate the same thing. It is not, why did I say that it is not your mom's biryani recipe or your mom's, aloo gosht recipe? Because if I go talk to my mom, what is the recipe of your biryani? She's gonna like stand by me because she knows the things by heart. She knows the stuff like, ek muthi ye, ek muthi wo, thod se chawal, things of that nature, but not the specifics. Hey, let's say, 20 grams of, rice, or, 0.5 grams of, red pepper, or, 1 gram of, star anise, or, things of that nature. So she will not have, those written down in a very, well-defined format. She will have things ready or remember, hey, what, this much of salt, this much of a pepper, this much, of the food color, maybe a pinch of food color, or a pinch of a salt, or 2 pinches of salt, So those are not very well defined. She knows it. She knows it by heart, but it's a travel knowledge to her. So that's the challenge, for us, for us desis. But if I look into, the Gora aspect of it, the baker has everything, printed, published, and, very well defined for a very specific task. Another one is, method to solve any mathematical problem, say you have a quadratic equation, um, or let's say, you have to solve something related to geometry. Say, you want to find the circumference of a circle. So there is a specific formula for it, for the identifying the circumference of it. And so, they are, very well defined, formulas for a very specific task. Circumference formula may not help me out identifying the volume of a triangle, as an example. Okay, the process of doing laundry, this one exactly, the functionality of a search engine, like how does Google search works. Like one of a brother, he asked a question about the searching. Um, so that prediction, brother, is based off of a couple of things. One is, say if I am searching it from Chicago, and the majority of the people from Chicago search things of the same nature. Say, if let's say, we know that, there was a prediction of snow yesterday. So let's say yesterday morning, if I search Google, is it going to, if I start typing in Google, is it going to, then it will start giving me the predictive text. Is it going to snow in Chicago? Is it going to, or, a couple other things, a couple other, predictions, it is going to provide to me. So that is, the geolocation based, predictions. There are predictions like, what is very common these days. So, like if people start, searching around that, it will start, giving you predictions or, predictive text, on that. So yes, the AI algorithms, they are sitting behind it, and they are actually, giving you, those predictions. So at times, if we feel that, computer or, Google, it is reading our mind and, giving us, those answers. Um, but yes, they are smarter now. Say if I have, let's say, I can give you example a couple of years back. It's a funny example. A couple of years back, when Facebook was optimizing on their AI algorithms, and so back then, I had the Facebook app on my phone, which I was, very frequently using at that time. Um, I started seeing um, ads on um, the hair transplant. Like Facebook starts sending me hair transplant, advertisements. Like this company is offering this company is offering that. And I'm like, what is happening here? Why are they? Why is what is Facebook doing, and why are they giving me all this? Then slowly, gradually, I find out that they have those algorithms that actually goes and checks my my profile pictures, and things of the like uh, the uh, the feature set that was already given to them on through my Facebook profile. They were able to start labeling it, and then offering me the advertisements that could be of attention for me. So that's one more example of it. So coming back here again, so what is an algorithm? It is a set of well-defined instructions performing a specific task or solving a specific problem. There are some common types, but the list doesn't stop here. I just put some examples here. They are mainly on the computer science. Those who are interested in CS, who are going to learn CS, which is computer science, or have been associated with it in the past, or maybe currently, they would know like sorting algorithms are one, sorting, searching, and graphing, recursives, divide and conquer, and there are a lot more. It all reminds me of my undergrad days. I believe we had, I think, two classes. One was specifically on algorithms. So at that time, yes, um, there were a couple of thick, really thick books that we had to study for the algorithm. Those who are interested in learning more, there are several books out there. You can get it from your library. I was actually, while I was preparing for this course for you guys for this class, so there were a couple of them um, which I got from my local library. One is this book. If and I'll see if I could take a picture and send to you guys if you are interested in learning more about the algorithm. So this is about the 9 algorithms that change the future. The another one is this is more of a textbook that is about the algorithms by Robert Sadowik. So these two books, they will give you some deep understanding on algorithm. Those who are interested in, and I'm going to come to it in coming slides. How can you tailor your career, in that, say, in the specific algorithm area, and then run with it. There's another good book which is by Malcolm Frank and a couple others. This is about the when machines do everything. How to get ahead in the how to get ahead in the world of AI, algorithms, bots, and big data. Uh, these 3 books, pretty pretty fun to read. If you are into reading, yeah, I'll take a picture, or maybe I'll send you the name in the email. If you feel free to get those books from your local library, or those who are in Karachi, maybe from Urdu Bazaar, or what was that place we used to get uh, the old books? I think it was Khodi Garden from Karachi. I'm not sure if that place is still there. Anyways, okay. So this is about the algorithms. Next one is, what is an AI algorithm? AI algorithm, keeping algorithm in your mind. What is an algorithm? Well-defined instructions, specific problem is particular task, right? What is AI algorithm? AI algorithm is they use, in the field of AI, set of instructions enable a computer program to learn from the data. Okay, these algorithms are designed to mimic the way the human brain works. This is new, right? Because the previous algorithm example or definition, there was no such thing as human, um, right? Human brain, or the like mimicking the human brain. But this is the capability of AI. It has not gone to that point yet, but it is slowly, gradually, it is going, taking steps, toward that direction. Also, by learning from data. Learning from data, learning is the capability of AI. Okay. Learning from data, AI can improve their accuracy and make better decisions over time. This is the capability. This is the scariest part for me, to be honest with you. Why? Because it learns from its mistakes. It learns from the the more data set we provide to AI, the more learning, the more finesse it will create in its predictions. So this is, one of the um, I'm sorry, this is, one of the scary aspects of it. So it learns, from the past, or from the data. AI algorithms, they are used in a wide range of applications, predictions, or, marketing, to diagnosing, diseases in healthcare, or the, controlling the autonomous vehicles, in transportation. So there's a huge spectrum out there. And then on the right hand side, you see some of the example algorithms. This is not the exhaustive list. This is the commonly used algorithm that I thought that, I should be, putting out there. A decision, on the right side, that you see, decision tree. Decision tree is the one, it's a tree-like model, like upside down, root model, or maybe, like, from root to the branches, that model. It is often used in business and finance to make decisions on large amount of data and neural networks, and random forest, reinforced learning algorithms, you will see, more, as we proceed along. So this is a, come on, sorry. So this is algorithm. This is one of the use case you see. The tabbed one are uh, the use cases of, each of them. Just to, give you guys understanding, for your future learning, or, if you want to refer it, down the road. So AI algorithm, same thing, same algorithm principle, but used for AI specific task. Um, AI specific task, could be learning from the data, or mimicking the human brain, or, using the mathematical models to analyze and find the patterns in large data sets. Previously, like before the like AI has been, for a while, but lately, the tools that are, currently available, the compute power that is currently available, that actually helps AI flourish more in the last, I would say, couple of years. And so previously, the finding some patterns in the large data sets was either a time consuming and compute consuming task, which is now, getting better and better, as we proceed along. Um, Now, I'm going to move on to the next one. Next one is about the confusion matrix. So I'm going to pause here. Do you guys want to take a break for 5 minutes, or do you want me to continue on? Anybody?
Faisal Bhai, it depends on your energy.
But I'm full of energy. Yeah, let's okay. Take a break. Let me see if I can pause the recording. Okay, I cannot pause the recording. I can only stop it. Okay. All right. So I'm gonna keep the recording going. Let's take a 5-minute break right now. It's 7:08. Okay, so you guys need a Fajr break. Do you think you guys be back in 10 minutes? Anam and Mohsen. Okay. All right. So right now is 7:08. It's 08 past hour. So by 18, let's see, no return back. Let me get this. Timer. I'm gonna set the timer for 10 minutes. Okay. All right. Those who want to take a break, please do so. Let me quickly get my water filled in. I'll be right back. Okay. Those of us who are around, do you guys see my picture, like my video, or is it just my screen which is showing?
I see the timer.
Okay. All right. How about now? Is it just a timer, or do you see my?
No, so now it flipped. So like where your picture was in the corner, that's where the timer is now.
Okay. Okay. About now?
Yeah, so like I
So
see
the
the
screen.
timer, but then in the corner I still see your picture. I'm using the browser version of Teams, so
Okay.
I don't have
Perfect.
like those reactions and everything, but I
No, that's fine. I just wanted to confirm that because I'm checking on my iPad. It's just showing the timer, not my picture. So I was just wondering. But anyways, it's okay. You guys know, I mean, you guys know my face, so okay. 5 more minutes. I'll be right back. Okay. All right. Sounds of y'all. Are you guys back?
Welcome back.
Welcome back, sir. Okay, I think let's get started. I actually have to finish right on dot. I have to go to Husaini for the Jashan and the Amal. So, those who are coming to Husaini, inshallah, I'll see you there. Okay, alrighty. So another topic, confusion matrix. I'm not gonna go deep dive into it, this one. But if you are interested, we can always sit, or I can have another session with you guys if you want to know more about this confusion matrix. It's pretty straightforward. It's a 2x2 matrix. There are more like 3x3, 4x4s as well. But the very basic and the one that actually does the work is a 2x2 matrix. 2x2. Why it is 2x2? You see that two fields here. 1, 2, two fields here. 1, 2. So 2x2. These are, the four fields here, right? So the top one is the top two. They actually are labeled as predicted. And on the left, you are seeing they are labeled as actuals. And on the predicted and actual, you see a negative and a positive, and the same thing on the left hand side, negative and a positive. So it is a combination of negatives and positive in x and y axes. So you see that the combination is, or the product is negative negative. So it'll be true negative, like two negatives, right? And then positive and negative is false positive. Negative and positive is false negative, and positive is true positives. Okay, and we'll come to it in a bit. So on the left hand side, you see that it is a performance measurement technique in any of the ML classification algorithm, or do not worry about it. It's a confusion matrix is a performance measurement technique. It measures that how is my algorithm, which I have put together based off of the feature set and the labels it is giving me. Remember, feature set input and the labels, the output it is giving me. Is that algorithm giving me enough confidence that I can use this model for my future use, or for my production use, or for my business use, or my personal use, or whatever, right? So it is the performance measure. It is used to evaluate the performance. Example, classification accuracy can be misleading when two or more data sets or the classes are are in use. And also calculating the confusion matrix help ML engineer, which is you, inshallah, in coming days. It is going to help you understand the effectiveness of the model. The model or the algorithm that I am implementing on this specific data set, the results or the labels it is giving me, what level of confidence do I get off of it? Okay, now look at the right side of the picture, or right side of the slide. On the top, we are saying predicted, that either I am predicting positive or I am predicting negative. Just the two just the two predictions I have in my model. My my machine learning model, it predicts only two things, either a negative or a positive. Okay. Now on the other side, you are seeing the actuals. Actual is showing me either it is coming out actually as a positive or as a negative. So prediction and actual. Okay. So if I am predicting negative and it is also actual, it actually was negative as well. That means my result is a true negative. That means this is what I was looking for, and this is what it turned out to be. Another one is if I am predicting positive, that this thing is positive, and in actuality, it turned out to be as positive as well. So positive and positive, this is a true positive. So these two are these two truths, the true positive and true negatives. They are the actual, they are the results what I was looking for, and they are the results, it turned out to be, or it is, churning out for me, or it is spitting out for me. So these are the, that's why they're shown green, just for your understanding. Although other than that, the color does not have any significance here. On the other side, say I am predicting positive, but the actual turned out to be as negative. The result is called false positive. False positive. That is also called type 1 error. Okay, I'm going to come to it in a bit. On the other hand, say if I am predicting it as negative, but it turned out to be as positive, the result is false negative. False negative. That means what I am predicting, it is going against it. Okay. What I have predicted, it has gone against it. What I have predicted here as positive. Oh, sorry. What I predicted here as positive, but it turned out to be as negative. So it has gone against what I predicted. So if the model is going against, that is the false. If it is against the prediction, whatever the prediction is, if it is going against, say I showed it a mouse. I showed it a mouse. I was expecting a mouse, but it tells me that it is a pen. So the prediction, it has gone, against the prediction. So it is a false positive. Now, what is the why it is called confusion matrix? What is the importance here? Why am I emphasizing on it here? Say as an example, if let's say there's a terminally ill patient comes in, and let's say the X-ray results comes out, the computer vision model was running AI, and it predicted the person has a cancer in his lungs, for example. Like the X-ray of a lungs came out, and it predicted that the person has, let's say, terminal stage of cancer. He's not going to survive. He's going to die pretty soon. But the result, so that's the prediction, right? But the actuality, it was the wrong prediction that was done on that, on that computer vision. It confused it, and instead of the true positive with instead of the true positive with the true negative results, it gives those false results that actually is going to take someone's life, or maybe a lawsuit on the doctor, or that is the whole 9 yards of it. So the accuracy of the predictions is very important when it comes to machine learning. It's not just only the healthcare. It could be anywhere. Let's say let's say I applied for a credit card and it got declined because of some XYZ reasons, and XYZ reasons find out that those were the AI actually ran it wrong, and it gave the false negative or false positives, not the actual truths, it gave. So, I was, declined, the credit card. Or, let's say if somebody, as an example, somebody is standing on the, or somebody applied for immigration visa, they got declined or they got denied because of, some, the feature set that was, um, posted into the system. So the accuracy of the system, or how accurate the results are coming out, it is of very critical importance. Yeah, weather forecasting, yes, most weather forecasting is another example. How many times have you seen that, there was a forecast of, let's say, 90% chance of rain, where, there wasn't any single drop, in your area. Although it did rain in somewhere else, but not in your city or not in your vicinity. So, there are some examples, of that nature as well. So um, the bigger the data set we provide to the system or to the algorithm, the better labels or better results we expect from it. And, it turns out, better results. So confusion matrix, just remember at this time, you do not have to go deep down on it. It's a 2x2 matrix, uh, prediction negative positive, actuals negative positives. When the two negatives collide, or when the two positives collide, that's the true negative and true positive. But if they do not, then either they are false positive or false negative. False positive is called the type 1 error. False negative is type 2 error. This is, confusion matrix. It's not just only in the AI, in other areas, it is in use as well. Those who are in security, like CISSP or CCSP, that, this terminology comes, in those exams as well. And in a couple other areas, you can see that. So, that's the, overall gist of, confusion matrix. I'm going to go to the next slide, give you some more examples here. You see on the right hand side of the screen, you see that, let me see if I could. Okay, yeah, I can bring, yeah. All right, so you see that, the actuals, positive, negative, predicted values, positive, negative. If it's a cat, and system predicted, on the blue box here, you see that, system predicted that you are a cat, that it is, true positive. If the system predicted, um, on the left and bottom left, you see that, the actual is a dog, and, the predicted value is you are a cat. So it actually, predicted wrong. So, it's a negative there. And then, same as the type 2 error you see, for the cat, it's negative for the dog, but, like it is, it picked up a dog on a cat picture. So I guess, you got the gist of it, that, what it is, telling us. So you see that, positive, negative, true, true, and then, the false, false. I'm not gonna go in the detail here. I will let you guys, once you have the, I'm sure, you will have, this the slide deck. Hopefully, if not tonight, hopefully by tomorrow morning. So along with the recording as well. So here, um, I'll let you guys go through, read through it, definitions and what it is, why and when. This is going to be used for. Feel free to ask me questions afterwards once go through this. Moving on to the next one. This is the confusion matrix calculations example. I did not go in detail on the example. I will send you the URL of some of the examples, and also I'll find out if you are interested. I can find more content for you, maybe on YouTube and on the web as well. This is helpful in using in finding the accuracy. How do you find that how do you identify the accuracy of your machine learning model? This is the formula for that. Number of correct predictions over total number of predictions. So number of correct predictions is true positive plus true negative divided by all four. TP, FP, FN, TN, all four of them. Whatever the number may, comes out as. what is the precision of my system? How precise it is um, in churning out the results or the labels for me. The formula for that is TP over TP plus FP. Same goes with the recall. So not gonna go in detail. You do not have to worry about it at this time, but it is good for learning if you want to learn more. As I said, we'll provide more information there. Okay, confidence level. It is the acceptable level. Sorry, the acceptable confidence level in machine learning. It depends on specific use case and context of the problem that is being solved. In general, the acceptable confidence level is, it is determined by the level of risk with a false positive or false negative, what it is. As I said, as I gave you, two examples, a person, on a deathbed or person not on deathbed, sorry, a person on a, went to a doctor, find out that, he is, you know, uh, about to die or he's, terminally ill because of, results that were false positive on his, on his X-ray or X-ray exam. So this is the level of risk associated with those, false positive or false negatives. Um, I gave you, I provide two examples here. One is the medical diagnosis. In medical diagnosis, the higher level of confidence is required, 95% or above. Okay, because we don't want it. We don't want systems. Because healthcare, that is directly associated with someone's life, right? So we do not want those healthcare systems to predict something which may cause, problem down the road, not just only for the patient, but for the doctors and the administration as well. So 95% and higher is the confidence level that is, that is looked into or required, to be, on those systems. But on the other hand, the other example that you're seeing, in a marketing example, um, marketing here, the confidence level is 80% or, as low as 80% is okay. At times, I've seen like 70% as well, because, that is not a deal breaker if the system predicts, something, of a lower value, or if it, and also, it is not, causing any harm to the business, or it is not causing any harm to, some human life or any, any life, out there. So, a lower confidence level is also, acceptable. Also, the acceptable confidence level depends on the trade-off between the accuracy and the computation. That is of importance, computational resources. When you have, let's say, you have a data set of, let's say, 1 million records, and you are training your system, let's say, with half of it, like you use 500,000 records you set aside for the training purpose of your model, of your ML model. Now, out of those 500, thousand, that while processing those, that requires a level of computational power, like CPU power, the memory, and all that, right? So it requires a lot of computational power. Do you have that, or does the business, or do I have that available, for me? So that on that depends on it, like how much time can I put together or set aside to train the model, based on those data sets. So this is the confidence level depends on how much computational power I am providing, and how much what level of accuracy do I require. Once I go do the demo with you guys, so I'll show you um how do we get around that, because this thing is not free, like Azure ML or AWS ML or GCP ML services. They are not free, they don't come cheap. So for the demo purpose, we're gonna use a small subset of our data set, and we're going to use a very smaller size computational resource, like a small size machine. And maybe we're going to run it for a couple of minutes, not for hours or days or months, so that we could just churn it out real fast, just to show you guys that, hey, what, this is the result. But this is for our personal play around a playground, right? But when it comes to the business, they have specific budget set aside, and that's a whole different story there. So and also, you see the higher confidence level requires more data. You see that. And, low confidence requires, it can be achieved with the smaller and more, efficient models. And, you see the summary here. I'm not gonna, drain that slide for you guys. So confidence level, just remember, 95% or higher for medical diagnosis or the healthcare, or let's say, the financial systems, depends, that how critical is that system. If that system is running production, but it does not require any, deep level of, accuracy, I can live with that. And, we can, or the business can live with, lower level of, confidence level. We can, play with it, and we can have, a smaller machine, or, smaller data set to train the model and come up with, with those results or the labels. Okay, moving on. Okay. I know we have seen this in our previous slide as well, like previous session as well. The difference between the AI, ML, and data, deep learning, or data science. Okay, so AI is a very general term. It's a bigger umbrella, general term. The definition is it's a technique to enable machines to mimic human behavior or think like humans, or walk, act, or act like humans, or think like humans. So it's a bigger umbrella. There is a subset within AI which is called machine learning. Machine learning is, so AI is a technique to mimic the human behavior, and then machine learning, it infers that, puts it into a niche subset, and it enables the machines to improve, with experience. Like, it learns, and more and more data, as we provide more and more data set, or more and more feature set to them, they actually learn from that. They keep on learning. So the bigger the data set, and the frequent the data set is fed to them, to the ML, to the machine learning, the higher the confidence level we're gonna get. Maybe, let's say, for example, let's say I provide 5 fruits to it. Apple, let's say, red apple, green apple, and, banana, grapes, maybe, and, let's pick, another banana, for example. So I provided 5 like picture, or the vision of 5 fruits to it. So it will learn that, it has 2 similar type of bananas, or 2 similar type of fruits that are looking like bananas. There are 2 similar types with different colors, but pretty much the same features. They are the apples, right? So it may churn out a result, but it may be not very confident. So it will be the ML model will not be confident in its tone. It will be like, maybe I think maybe it's a banana, or I think it's a banana. Now, instead of 5, if I provide, let's say, 500 different types and shapes and forms and colors and all that, right? So it will, keep learning, keep learning, keep learning. Then it will be confident. So, let's say if I show banana which is grown in Pakistan, or banana which is grown in, let's say, in US, or banana grown in Mexico, different shapes and different sizes, it will pick it up real quick. And, it may have, the confidence level above 95%. So the bigger the data set I provide, the better the learning, it will have. So machine learning, a subset of AI, and we may not be able to complete the ML slides today, but I'll try to knock it down as much as I can. And then there is another subset which is at the it looks it is sitting at the core, but it is a subset of machine learning, which is called deep learning. It's a subset, and it makes the computation of multi-layered neural networks. It utilizes neural networks, which is like similar to our the network in our brain, the neurons and all that, the connectivity and how things work. So once we go learn about deep learning, we're gonna learn more. We're gonna know more about neural network and how does it work. What is the forward chain, what is the reverse chain, and how does it work. So yes, rest assured, we're gonna learn more, in the deep learning side as well. So we're gonna go into a machine learning, which is subset of AI that uses the statistical model or statistical methods to enable the machines to improve, with experience. All right. Understanding machine learning. Right hand side, you see there are three tentacles coming out from the core machine learning. So machine learning has three major types. There are a couple more as well, but for you at this time, the three which are of the importance. One is supervised learning. Second is unsupervised learning, and third is reinforced learning. Give you an example. Give you a desi example here. Supervised learning that मैं नमाज पढ़ रहा हूँ तो अपने साथ में अपने बच्चों को मैं बार बार कि भाई आ जाओ लेट्स डू नमाज विद मी लेट्स डू नमाज विद मी कभी कभी जो है वो they're gonna be making fun, they're gonna be playing around, कभी सही से पढ़ रहे कभी नहीं पढ़ रहे आहिस्ता आहिस्ता but I am supervising them, तो आहिस्ता आहिस्ता वो supervision की वजह से they're gonna learn कि भाई नमाज कैसे पढ़नी है. Second is unsupervised learning. मैंने अपने बच्चों को बिल्कुल बस छोड़ दिया एंड देन दे फाइंड आउट अच्छा देयर इज अ थिंग कॉल्ड नमाज. अच्छा चलो उसने अपने किसी दोस्त को करते हुए देखा कि अच्छा ये उसके रिचुअल्स हैं, ये प्रैक्टिसेस हैं, और फिर उससे जो है वो उसने एंड ही पिक्ड इट अप एंड देन उसने फिर वो उस तरीके से पढ़ना शुरू कर दी कि भाई आई वाज नॉट सुपरवाइजिंग द पर्सन लर्न बाय हिमसेल्फ और हरसेल्फ एंड देन पिक्ड इट अप. रीइंफोर्स लर्निंग क्या है? रीइंफोर्स लर्निंग इज whenever मेरे बच्चे ने नमाज पढ़ी, मैंने उसको जो है वो क्या कहते हैं उसको रिवॉर्ड किया कि अच्छा यार दिस इज योर रिवॉर्ड, लेट्स से आई गिव हिम अ कैंडी. नेक्स्ट टाइम से फिर नमाज पढ़ी, मैं उसको कैंडी दी. थर्ड टाइम से नमाज नहीं पढ़ी तो मैं नाराज हुआ, मैंने जो है उसको थोड़ी पनिशमेंट दी कि भाई नो मोर आईपैड फॉर यू, लेट्स से फॉर 1 hour फॉर एग्जांपल, कि इस तरह की पनिशमेंट दी. तो रीइंफोर्स्ड लर्निंग इज अ टाइप वेयर वी um, uh, so in reinforced learning, we whenever the model comes up with positive results, we provide like we give them some sort of कुछ कुछ उसको गिफ्ट या कुछ इस तरह की चीज हम देते हैं. But on the and when they do not come up to that part, or they do not bring up that results, then we actually punish it differently. Punishment is not the right word. I'm just skipping out on the right terminology at this time, but we'll get to know more in our coming slides. So ML learning is a subset of AI, focus on teaching and training the computers to learn from data. If you remember, data and data sets, and improve with the experience instead of being explicitly programmed to do so. Explicit programs hote hain program. So we did program it. Hey, whenever you see this, just do this. See this, do this. So it's already programmed. So it is not going to think anything outside it. But here in the AI and the ML side, it actually learns. Okay, so I have this data. I'm gonna keep on learning whatever the data set is coming to me, so that I'm going to improve with the experience. I'm going to improve upon my confidence in that level and improve on my results. So algorithm is trying to find the patterns and correlation in large data sets and make the best decisions and predictions based on the analysis. So whatever the analysis comes out and whatever the data was fed into it, it will come up with with the results. And ML applications, they improve, right? Because they they keep learning, based on the data, was, given to them. Okay, application of ML. It may resonate with maybe some of you, maybe all of you. Application is pretty much everywhere. ML is, I'm telling you, it's everywhere. This is not the exhaustive list. This is, some of the areas which I could think of. The possibilities are endless, I'm telling you. Stock market trading, self-driving cars, traffic predictions, online fraud detection, automatic, language translation. There's tons and tons of opportunities out there. That's why I am emphasizing you guys, please maybe pick one area and just excel into it. Just go deep dive into it. This is the area I'm going to excel. I'm going to find the niche. I'm going to be the voice of that specific area at my work, at my community, at my home, in my family, or wherever, or at my school. That this is the area whichever the area you feel that you see some interest in, feel free, to deep dive into it. I'm here to help you out. If you need any help, if you want to know more, hey, you know what, Faisal, I wanted to know more about, let's say, the fraud detection system. How does it work? How do I get myself? I have the finance and accounting background, for example. How do I get myself into it? Or let's say my family, or my spouse, or my kid, he or she has an interest in it. How do I, or how do we? So I'm always open for you guys. Feel free to reach out, either email, phone, or whatever, right? So I can, have, I would love to have a, conversation with you guys in that area. Okay. So these are some of the examples, but it is pretty much everywhere, be it programming, be it, cybersecurity, if you are in the security field, if you are a Scrum Master, project manager, if you are cloud developer, if you are the program manager, if you are someone who is on the strategy side, or on the technology side, like, if you are a DBA, you have seen, those self-learning databases, the database, if you are into the application side, the self-learning, self-healing applications, lots and lots of, areas out there. So yes, possibilities are endless. Get yourself into it as early as possible. Okay. Enough harping on it. So moving on to the next one. Next one is the ML process. I'm not going to go in details on this. It's pretty straightforward. The top diagram, it takes the data from the data set. You provide the input, like you input the data into the developed model, whatever the model you develop, out of which you provide some for the training and some for the some for the training of the model, and then remaining you did for the production, or for the the further analysis. So you train the model, test and analyze the data. If you feel that the results are good, the model goes live, model goes into the production. If you feel that it requires for additional further training, so you provide back into the retraining, you tweak the training model, and then you send it back to the training model, have it train again, so that it comes up to the confidence level what you or what the business is looking for. Is it 95%? Is it 80%? Or is it 99%? Whatever the percentage they are looking for. And then once it is there, that the model goes live. The bottom here, you must have seen the infinite loop, which is the DevOps loop. You must have seen this loop, which is the DevOps or DevSecOps. Must have heard that. If not, that's okay. So the diagram on the right hand side, which I just draw here, that's the default DevOps. Like you continuously develop. This is the CI/CD pipeline. If you're wondering, you continuously develop, and then you have sprints, and continuously that is going to the operations, and it is going to the monitoring and all that, and so the cycle goes on and on and on. That's the agile way of doing things. Those who are in Shahid Bhai's class, The Scrum Master, that's what he talks about. He's going to talk more in detail on that area. So right hand side is the two, like is the actual infinite loop, but on the left hand side, this is a new thing which recently came out. And this is where I see a lot of opportunities for us. This is called the ML ops, machine learning operations. What it is that the one area is ML engineer. The guy came in, he developed the model, he trained the environment, or he trained the model based off of the data which is provided to it. And then guy just walked out, and the system, it just kept on running. So somebody has to manage this. Somebody has to run the operations of it. The data is keep on coming. Now maybe the data type is changing, or the requirements are changing, or things going to change, right? So that's where the ML ops, or machine learning operations, engineers, or the project managers, or the scrum masters, they're gonna come into the picture. So this one here, this is, I see an opportunity for us. If you cannot be on the left hand side, try to be on the right hand side. Okay. If you feel that, I cannot design, I am too young, I am too old, or I have zero confidence. Although, I mean, I do not, recommend this all, but, look into the right hand side of it, maybe in the, if not designing, maybe in the development, like somebody already designed it for me. I'm going to just develop the model based off of the design and just deploy it on somebody on the operation side, on the right hand side here, somebody, who's gonna handle and manage the CI/CD pipeline, the monitoring and the triggering, the monitoring aspects of it, the observability, this whole thing in the operations and all that. I'm going to talk in the very very last lecture, inshallah. So the more you go to the left, the more पैसा जो है वो left side पे है, in the design side, in the model development, operations and all that. That is a comfortable way of getting yourself into ML. But still, you're gonna be, handling and managing, the ML side of it. So operations there. Then, on the design side, the requirements engineering, somebody giving you the requirements, or you are collecting the requirements. Say, hey, what type? Why do you need this? What type? And also, you're gonna base on, uh, the input that were given to you. You decide what ML model we're gonna be putting in. So I'm gonna come to it in next slide. What model would it be? That is going to be helpful for you. Okay, here it is. This is the slide which I was talking about at the start of this class, today's session. So you see that model training, there are in the development phase, the training data, model training, model validation, production data, right? So there are different tools, you see MLflow, Apache Spark, Jupyter, H2O.ai. And at the bottom here, you see the models here, the PyTorch, TensorFlow, Keras, Node, Curl, R, Java, Python languages, and the libraries and all that. So pick a niche, pick one area, and then deep dive into it. Say that you are the voice of, let's say, PyTorch in your organization. You are the R guru in your school, or in your family, or you are the cares guru in your in your business, right? So pick one area, find your niche, whatever you are comfortable starting off with. Okay, although I want you to think outside your comfort zone. Okay, there are hardware and infrastructure area as well, like VMware, Azure. I'm gonna touch upon. I'll show you guys where it is, right, and what it is. Also I'll show you in the AWS area how and what are the ML or the AI capabilities or the machine learning capabilities in Azure as well, right? There are people who are just specific in this area, source code and the CI/CD. Like they define the pipeline, they operate and they support the pipeline, and then, they like CI/CD pipelines, they set up the pipeline, the master and the branches and all that. And then, if there's any changes required, they do that and, help out, work as, maybe a release engineer type work, right? So doing the version controlling and, and they, in the GitHub area. Also, you see that, on the data services, Azure has, the blob, which is the storage service, which is, like AWS has, the S3 service. Plus, the Snowflake is there, SQS is there. Lots and lots of, these are some of the examples. There are, several other out there. So use this slide as a stepping stone for you to get yourself, into the ML area. Okay, like I said, I'm gonna have to stop it here. Um, I know I have about seven more slides. So I'm not gonna. So next one is about the ML, and we're gonna go deep dive into it. So I'm gonna pause it here. Next week, we probably will have a 2-hour class as well next week because I need to cover ML and then, the 2 other areas as well, to, get that knocked down. So I'm gonna pause here for any questions, concerns, or comments, before I let me do one thing. Let me stop recording first.